Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
So good afternoon, everyone. My name is Kelvin Saidi, and I'm a biomedical engineer with the Oxygen Alliance. So I'll be your host for today's session. It is my pleasure to guide you through this webinar. So I'm joining from Lilongwe, Malawi. So I'd like to know where everyone is joining from. So please paste your name and where you are joining from. On behalf of the Oxygen Alliance, I would like to warmly welcome everyone to today's webinar on centrifuges. So we are truly grateful that you have taken this time to join this important practical session. We are honored to have an accomplished guest who will present this webinar. His name is Engineer Joseph Fernanda. He's a graduate medical engineer from the Technical University of Mombasa, and also a holder of the Bachelor of Information Technology from Jomo Kenyatta University of Agriculture and Technology. He is also the founder of Hospital Solutions, as well as the Technical Director at Velocity Management Limited. With this combined expertise in medical engineering, technology systems, and project management, Mr. Ananda brings a multidisciplinary perspective to equipment management and healthcare technology solutions. Without further ado, I would like to give the floor to Engineer Joseph. Over to you. Thank you very much.
Good evening, good afternoon, good morning, everybody, wherever you are. I think I've been introduced well. My name is Engineer Joseph Wananda from Kenya. Today we want to talk about a clinical machine called a centrifuge machine. We talk about the clinical application, technical maintenance, and we will dwell more on calibration. So I want to welcome everybody on board. Thank you for your time. Now, here we have a centrifuge machine. It's a laboratory device that is used in clinical procedure in separation of specimen or body fluid, depending on the density. So how does it work? In a layman way, it works by spinning sample in a very high speed to generate a force called centrifuge force. The application of this machine is basically on a clinical, medical, clinical research, and also in a larger scale industrial application. Just to go on a quick naming of the parts, you can see we have a lead with an electronic door lock. We have a hydraulic gas spring, stainless steel cavity, emergency valve, we have power switch here, we have temperature seal plate, we have food grade sealing ring, and a user interface display, and then with a control panel for the user interface. A technical overview of a centrifuge machine, which I think is our area, is how the internal part look like. We have a rotor here, which is attached to the motor shaft, which in turn is holding the tube during the spinning. This is where the centrifugal force is coming from the motor. Component of a centrifuge, we have a rotor that holds sample during the spinning. We have a drive shaft in attachment with electric motor, which is being controlled by power to create a rotation. We have a lead or cover as ensure safety for the user. We have a stainless steel chamber which encloses the rotor. We have control panel. This is where the user interacts with, we call it user interface, where you can set your speed, time, and other operational parameters. We have tube and holders which are linked with the shaft and motor directly to secure the samples. How do we use this machine? We apply this machine in clinical diagnostics, blood, urine, and plasma separation. We use in pathology laboratories. We use in research institutions and university, big pharmaceutical and biotechnology industries, blood bank and transfusion centers. In our area, as engineers, medical engineers, we are in an hospital setup. So medical and laboratory use of this machine, which is our area of interest, is used to separate separation of serum and the plasma from the blood sample. It can also be used in preparation of sample for hematology and biochemistry analysis. Can be used to separate sediments in the urine. Can be used also in the protein extraction from the DNA and RNA molecules. What are the types of centrifuge we have? We have clinical centrifuge, which are more applied in clinical setup, suitable for routine hospital and diagnostic laboratories. We have microcentrifuge, small volume sample PCR tubes, microcentrifuge designed for small volume sample and PCR application. We have refrigerated centrifuge. So very temperature sensitive samples are being operated using this kind of centrifuge. We have high-speed centrifuge applied in advanced research, laboratory and research institutions, university, etc. What are the key components, technical key components? We say your electric motor, drive the rotor rotation. We have rotor, all the sample tubes, all the buckets, control panel, charge the user interface, set up parameters, and creating of programs. We have safety lead that prevent the user from hazard. You have shock absorbers that reduce the vibration of the equipment itself. So this is a kind or a type of centrifuge rotor and bucket that enable a balanced and efficient sample separation. Typical technical specification of a machine, you have a speed of 4,000 to 15,000 revolutions per minute, a maximum RSV up to 20,000 times. We have a capacity, depending on the application, of 6 to 48 tubes holding capacity. The revolution time can be from 0 to 99, depending on the manufacturer specification. Most of the Africa, we have a power grid of 220 to 240 voltages. Nevertheless, you can still have centrifuge from the American grid, which are 110 voltages. Therefore, you will require to step the national grid down to 110. These are the operational features. We have digital or analog control interface, user interface. We have preset speed and time programs, low noise and vibration design, automatic imbalance detection, easy to create stainless steel chamber, easy to clean stainless steel chamber in case of any spillage. Now, this is the area of the interest for most of you. We have safety and maintenance considerations. We have to clean the stainless chamber after every use. So when you wipe rotor, buckets, and chamber with mild detergent, you disinfect. Any spillage immediately, especially blood and biological sample that can create a biological hazard to the environment surrounding. We have check balance, ensure tubes are evenly loaded. Before each run, there's a reason of this. For this one, we'll see it, the importance of balanced sampling. You inspect virtually, use face lid, look for cracks, corrosion, or loose parts. Lid locks if it's functional. Lid must be closed and locked properly before operation. You never open the lid while the machine is spinning. If excessive shaking, unplug immediately. There is a reason of excessive shaking. That means the shock absorbers are worn out. Never run a centrifuge with unbalanced load, creating wear and tears of the motor bearing. Daily maintenance, you wipe interior with the disinfectant, check for unusual noise. Weekly maintenance, clean rotor and accessory thoroughly. Check rubber seals and gasket for wear and tear. Inspect power cables and plugs. Confirm speed and time are functioning correctly. The monthly preventive maintenance, usually done by a technician or a trained staff, You need to lubricate motor bearings if manufacturer allows. Remember, there's some motor you can't lubricate. You inspect drive belt. If the belt is still in good working condition, you check vibration and noise during operation. There is any shock absorber which are broken. You tighten loose screws and mounts. You verify revolution per minute accuracy using tachometer test. Annual major maintenance performed by a biomedical engineer and service technician. You need to fully calibrate. What do you calibrate? Speed, time, temperature. If it's in a refrigerated case, you need to check electrically safety testing, check motor performance assessment, replacement of worn out parts, belts, brushes, seats, inspection of control board and sensor. So calibration certificate need to be issued upon conducting of this procedure. Case scenario of a refrigerated centrifuge, you need to clean the condenser and coils, check refrigerant pressure, inspect temperature sensors, ensure ventilation grills are dust-free by blowing the dust. Centrifuge calibration. Proper calibration maintain accuracy in revolution per minute, timing, and temperature, ensuring reliable results and compliance with standard. I will explain how you do this calibration. Essential calibration tools you need: tachometer, purpose it measure rotation, speed, optical or contact type, certified accuracy plus or minus 1%. You need a good condition working stopwatch, stop timer, verify centrifuge timer, digital or certified. Need a thermometer applicable for the refrigerated centrifuge machines. You need reflective tape for speed measurement. You need PPE, that are gloves and goggles when you are doing your test for your own safety. Step-by-step calibration. Preparation, you need to wear your PPEs before you begin your calibration. You disinfect the centrifuge, place reflective tape on a spindle. Speed verification. Load balance sample, run at a set revolution per minute, measure with tachometer through the viewing point, acceptable 5% difference. Sorry, somebody is interfering with me. Let me put it off. Okay, we go for speed verification by using tachometer. Okay, you measure the rotor speed. This is where the origin of the speed. You measure the rotor speed with a digital tachometer. So how do you do it? You start by setting up a set test speed. So you can create a common speed figure, 1,000, 3,000, or 5,000 revolution per minute. You run a test, run with the centrifuge at each speed, measure and record. You compare the reading, check if the measured revolution per minute matches set revolution per minute from the machine. If they don't set, you can calculate an error in terms of percentage. If the error lies below acceptable minimum error, that is 5% minus or plus and below, you can proceed, use the machine. If the errors goes beyond the acceptable range, you will be required to adjust if needed, by following the manufacturer instruction. How do you calibrate timer? You calibrate timer by using a stopwatch. So get a calibrated stopwatch. Even your stopwatch need to be calibrated. You don't calibrate the timer using an calibrated stopwatch. You choose a test run time, for example, 5 minutes. You need to run the centrifuge. You start a centrifuge and a stopwatch together concurrently. You compare the readings, check the centrifuge display time, and at the same time, you monitor the stopwatch. You calculate the error in form of percentage. Also remember the acceptable error range 5 minus or plus 5% and below. If the timer range above this one, you need to calibrate by adjusting as advised by the manufacturer. Another important calibration is in temperature, especially for those refrigerated centrifuge. This one, you'll use a thermometer, verify a set versus the actual temperature. The most important thing in calibration, we call it, sorry, it was not here, but I can advise, you need to calibrate the balance of the centrifuge. The centrifuge, how it balances on top of the work table is very important for wearing and tearing of the motor. You use a balance weigh scale or a calibrated tools. You check manufacturer guidelines. You load the rotor symmetrically, test the balance tubes. You need to test if the tubes, test with the balance. You run a test at a very allowable speed. Check the imbalance alarm, if there are any. If the imbalance alarm indicates that the machine is not balanced, you need to adjust and calibrate accordingly. The balance go hand in hand with the vibrations. So you use a vibration meter to measure vibration level at a rotor level, run at an operating speed, check vibration are within the specs. You compare the limits, and if it doesn't give you the acceptable calibration set range, you will be therefore required to adjust accordingly. After calibration, a fixed level with date, result, and next due date will be recorded and displayed. A certification need to be provided for future reference. What are the common problems we encounter with this machine? We have excessive vibration. Likely cause will be unbalanced load or worn out bearings. The machine won't start. There is a lead lock fault or power issue. Remember, the lead lock is a safety device that is a safety in relation with the user. If the lead is not well locked, therefore the machine won't start. So probably the lead lock is faulty or the power is not getting into the machine. Another common faults are wrong speed. These are control boards or sensor issues. So from the control board, you need to calibrate the allowable operational speed, or we check the speed sensor, or rather just do a calibration. Another common cause is loud noise. Once the machine is running, there will be a lot of generated noise. This indicates that the bearings or motor are worn out. We have wear and tear within the bearings or motors. We have overheating. This could be as a result of poor ventilation or motor faulty in the motor, which is causing heating effect from the machine. So probably the coil motor are gone, or in a refrigerated case, we just have poor ventilation. In conclusion, centrifuge machines are essential in modern healthcare and laboratory services. A proper selection depends on the application, capacity, and technical requirements. Reliable performance ensure accuracy in diagnostic and research outcomes in the machine application. That makes an end of my presentation. I will accept any question, any verification, any clarification. Thank you all for listening. Thank you.
Thank you very much, Engineer Joseph, for the wonderful presentation. But before we go to the question and answers, I would like to briefly highlight the best LMIC journal that the Oxygen Alliance published on the 7th of February. So it is a for engineering systems and technologies for low and middle income countries. So for a long time, engineers in low and middle income countries, we develop ideas daily, but we have no platform to publish them. So not anymore. So Best LMIC provides a dedicated peer review platform for publishing practical, context-appropriate biomedical engineering innovations that are designed for these rural resource settings. So we invite you all to contribute and help build a stronger evidence base for healthcare technology in low and middle income countries. Moving on, let's look at the questions. So I'll start with the questions from the chat. The first question was from Mr. Peris Geruto. So he was asking, is the reflective tape used in speed calibration? So I will repeat the question. Is the reflective tape used in speed calibration? Could you please unmute your mic, please? I don't know if you got that, Engineer Joseph.
Come again, please. There's a noise behind, from the background.
Yes. All right. So the question was, is the reflective tape used in speed?
Reflective tape.
Yes, when you're conducting a tachometer test.
Yeah. The tape, you use it with a tachometer. Yeah, and the tachometer, we have different model of tachometer. So you use the reflective tape to induce the signal when the rotor is revolving at a very high speed. So there's a reason why we use it. It's used, yes, for calibration. So you'll use the tachometer to point where the tape is.
All right. I don't know if that answers your question, Mr. Peris. Before we move on, I see a thumbs up. So thank you for that. Before we move on, Engineer Joseph, could you please continue sharing the presentation, if that is okay? All right, we have another question from Victor, and he's asking, how often should calibration be done? How often should calibration be done?
Annually. We indicated it's a major maintenance and preventive done annually. I think it's here. Just a moment. Can you be able to see my presentation?
Yes, we can see.
So weekly, monthly, annually. It's here. It's done annually, and you provide a certificate for it once you are done. And the record should be clearly indicated in the data sheet.
So I see a thumbs up from Victor, so I think he has been answered. We have a hand raised from Good Luck. Good Luck, could you please unmute your mic and ask your question, please?
Okay, can you hear me now?
Yes, we can hear you.
Okay,
yes.
My name is Good Luck Oboro, biomed from Nigeria, Bayelsa State, to be precise. I then follow up from the inception of the presentation because my network was poor. However, I had something like refrigerated centrifuge. I've not heard of it before, so I don't know what it's like. I don't know if just a few little representation or highlights from the beginning to throw more light on it. I missed one or two things, so that's just what I have to say. Thank you.
Moderator, can you clarify, please? It's looking for the slides.
Yeah, so to summarize, he was just looking on clarification on refrigerated centrifuges. So it seems that it is his first time appreciating these machines. So he would just like maybe a further explanation or a re-explanation of the device.
Yeah, in refrigerated centrifuge, we have some case scenarios where the samples need to be operated under very low temperature. Such kind of sample, they will only be separated by using a refrigerated centrifuge. This is just to maintain the temperature of the sample as required and advised by the clinicians. So they don't require normal temperature. They require refrigerated environment. So that is the unique case scenario or the unique application of the centrifuge. It's not commonly applied. It's in a very rare occasions. And its calibrations is basically checking on the time, the temperature, and the refrigerant. And its maintenance just to blow the dust. You just need to blow the dust.
Hello, Engineer Joseph.
Yes.
Sorry, I think we could not hear you for a while. Please maybe repeat the last 10 seconds.
Yeah, I've said that in a refrigerated centrifuge is applied in a special case scenarios where the specimen is required to be applied in a very regulated low temperatures. So that's why my colleague from Nigeria rarely came across such kind of machine. It's applied in a rare case scenarios. So just like normal refrigerated appliances, you need to check the refrigerant for leakages, you check the timer, then you blow the dust from the filter side. So that is, and also check the sensors, the heat temperature sensors. Okay, so that is the normal maintenance checkup on the refrigerated centrifuge machine. Unless there is anything I need to clarify. Yeah, here what you need to check during maintenance. You clean the condenser coil, check refrigerant pressure, inspect temperature sensors, then ensure ventilations, grills are dust-free. Yeah.
Right. Wonderful explanation. I don't know if Mr. Goodluck, I don't know if that answers your question. All right. So before we go to the other questions, the link to the best MIC journal will be pasted in the chat. So it will be pinned. So just open the link and then go to the website and appreciate with the Oxygen Alliance is doing. Moving on, we have Mr. Philip. He has a hand raised. Mr. Philip, please unmute your mic and ask a question. Thank you.
Good evening, everybody.
Good evening, Engineer.
Yes, thank you very much, Engineer Wananda, for the good presentation. I just wanted to make a comment on calibration. Yes, calibration is done after 1 year. A certificate is issued, but it is good. It is done by a third party. You cannot calibrate your equipment. You can verify the speed of your equipment and make sure that it's running within, but that is, we call it the verification. That's why you have it. That's what you do after maintenance, after service, just to be sure. But calibration, you cannot calibrate your own equipment. It is a third party that does the calibration and issues certificate so that you can have the confidence that your machine is working within the accepted parameters. Thank you.
Thank you, Engineer. Clarification.
All right. Thank you, Mr. Philip. We also have a question in the chat. It says, does the weight of the sample weight influence the time and the rotor speed? Does the weight of the sample influence the time and the rotor speed?
Yes, the answer is yes. Remember, every machine is designed or manufactured to hold a certain weight of samples. So once you overload it, you will put a lot of tension in the motor bearings. The force will be exceeded as per manufacturer guidelines. So if you want to use a sample with more weight, you'll be advised to do your machine selection keenly. You can if it's for the case of an industrial research centrifuge, will require a bigger one. So you're supposed to check the data sheet. I think this is more applicable on the clinicians. Yeah, it's more applicable. They need to check what kind of weight a machine can hold. I think that is sad, unless they need more clarification or somebody can add something on it. but yes, it does affect the tension in the rotor and motors.
All right. Thank you for the explanation. I hope you are being answered, Mr. David. Moving on, we have a hand raised from Ibrahim. Ibrahim, please unmute your mic and ask the question. And next, I'll go to Mr. Daniel to ask his question again. Thank you.
All right. Thank you. And engineer, thank you for the presentation. So I have two questions. I don't know if I will just send the question to you. Maybe you just answer it. The first question is, how can we use the tachometer? And also you talk about the positioning of the centrifuge, and I didn't have get more light on that. I need you to have an quick brief about what you said, because I didn't hear it very well because I have a poor connection. Thank you.
Okay. So in tachometer, you use it for measuring motor speed, revolution per minute. By using the digital tachometer, you need to put a reflective tape on the top of the revolution shaft, revolving shaft. You need to set a common test speed, for instance, 1,000, 3,000, or 5,000. Then you run your test. By running the test, you will be noting them down. And then you compare with the data sheet from the machine. If the revolution matches the set revolution per minute from the machine. Now, if there is a way you calculate the errors in terms of the percentage. If the percentage lies below minus or plus 5%, then your machine is still within normal working range. If it goes beyond 5%, then you will be required to adjust the speed from the user control panel, user interface control panel. I think that is understood. Now, on the other question, the reason why we should put a machine on a level surface, we did to minimize the vibrations. Remember, the vibrations, once the machine is revolving at a very high speed, might create some internal mechanical damages from the motors, from the bearing, from the seals, etc. So how do you check if the machine is in a level ground? You use an instrument called vibration meter. Vibration meter will measure the level of vibration of the rotor. You run at an operating speed. You check if it's aligned with the indicated standard procedures. If it is not, if the vibration is too severe, probably you need to check other items like motor, bearing, shock absorbers. But if it's a thing of the surface, the unflat surface or an even surface, therefore you will be required to readjust your machine. That is how you fix the uneven level of the machine. But indeed, if the machine is not in an even surface, depending on the revolution of the force, it might create a severe mechanical damage within the internal part of the machine. Thank you.
Thank you so much for that. And I see a thumbs up from Ibrahim. Next was Engineer Daniel. He raised his hand. So if you have any comment or question, now is your time. All right. Moving on, I will read a few questions from the chat. So there are two questions. I will combine these two questions. It is from Victor and Perry. So it reads, what could be the possible causes of centrifuge failure to reach a set RPM? And the follow-up to that is, in case the RPM is found to be out of range during calibration, what adjustments would you make?
Okay. I think as Engineer Philip have insinuated before, that it will be required that calibration is handled by the third party. If the RPM is not within the normal range, what you need to do is just to adjust the parameters by the use of user interface control panel. There is a way you can adjust the speed, the revolution per minute to appear be within the acceptable operational range. The other question was if it exceeds, right? If I get you wrong, the other question was if it exceeds.
So the question was, in case the RPM is found to be out of range, what adjustments would you make? So I think we answered that. Yes. So Victor asked, what could be the possible causes of centrifuge failure to reach the set RPM?
Uncalibrated parameters.
All right.
So there is so many factors that can lead to that question. We can have a minimum operational output of the motors as a result probably of mechanical damages. But the main one is uncalibrated parameters. So it doesn't reaches the required RPM standard. So all these things revolve around calibration. I think that is why Engineer Philip insinuated that the calibration should be done by a certified third party for verification and clarification. So it's very important that calibration should be a routine operational standard procedures within the clinical facilities that are utilizing such kind of equipments. Thank you.
All right. Thank you, Engineer Joseph. Engineer Philip has also raised his hand.
Yes. I just wanted to chip in there. The centrifuge can go out of its speed because of wear and tear. And what are the parts that you need to check first before you adjust the speed port? Check the brushes, the parts that wear. As Engineer Wanda has said that, Wanda has mentioned that mechanical and what have you. You check the parts that wear, check the brushes, check the balancing, and all those kind of things, which you can cause which can wear out. Of course, with use, things wear out. That's why we need to do maintenance and service. And if you notice there's something to be replaced, you replace it with the time. Then after you have checked those things and you have serviced your centrifuge and it's still out, now you can go to the port. You go to electronic board, which is the only biomet that can go there. You check the board that controls that speed, and then you can adjust that, the port, and see if it's dropping again. Thank you.
Thank you, Engineer Philip, for that additional insight. And I see a thumbs up from Victor. So it seems his question has been answered. Moving on to the other question is, so someone is asking, where do you actually put the tachometer when doing the speed test?
Engineer Wananda, are you there?
Yes, I'm there. I'm just checking on the speed. Yes. So the whole revolution speed is being brought about by the motor. Okay. So what we need to do is you take a reflective tape in each and every position where the motor is and direct the tip of tachometer directly to the reflective tape and then do a test run, but you should hold it in a position by recording. Once the machine is running, you record, and then you compare with the standard operating parameters. You compare. So it will be directly to where the motor is, the motor and the shaft. Is he answered?
All right. Thank you for that. I don't know if you have been answered, but Moving on, I will take, yeah, I see a thumbs up. So thank you for that. Moving on, I'll take 3 more questions from the chat. So I'll just read them. The first one is, in which category is the centrifuge classified? That is the first question. The second question is the PCR machine the same as the centrifuge machine? And last but not least, how will you fix inconsistency in the duration of time running, even after calibration? Over to you, Engineer Joseph.
Okay, can you read the first question? Which category is?
The first question reads, in which category is the hematocrit centrifuge
Classified.
Yes.
Okay, let me note them down. Centrifugation.
The second question, is the PCR machine the same as the centrifuge machine?
Okay.
And then the third question, how will you fix inconsistency in the duration of timer even after calibration?
Okay, centrifuge is categorized hematology centrifuge, right?
Yes, hematocrit centrifuges.
Can I close this window so that I access the question directly from the chat? Huh?
Yes, yeah, that's okay.
So good luck. Oboro is asking, is the PCR machine the same as centrifuge? No, they are not the same. Okay.
All right. I think you may move on to the next question, Engineer Joseph.
Hematocrites. Okay, this is a very unique case scenario. Yeah, this is a very unique case scenario. I think, according to me, okay. It measure blood. I think hematocrit also deal with the blood cell sampling. Yeah, but the classification should be under the. I need to do more research on this. I don't want to tell something I can't verify, but I think you can link me with the engineer. I will answer this question once I get the facts. You know, in our profession, we don't just say things without verifying. So I will answer. I'll do research more on this and I will answer you, if you don't mind. What is the other question?
The other question was talking about how can you fix inconsistency in the duration of the time running, even after you have done your calibration. So it is the last question of the chat.
So that is the timer calibration, right?
Yes, correct.
Yes. So this one, you need to have a calibrated stopwatch, okay? As we said before, you need to have a calibrated stopwatch and you set a preset time interval, let's say 5 minutes. After every test run, you record 5 minutes, and then you compare the reading, okay? So you can do the first test run, you start your stopwatch, and you do your recording, you stop, you start again the next 5 minutes, and then you compare the readings with the displayed time versus the stopwatch time. Then you get the average in terms of the percentage. Yeah, I think he's answered.
Yes. So I think this Max.
Yeah, there is an engineer called Irene would want to comment on hematocrit. Can he say so? Can you give him give a chance to say something?
Yes, Irene, may you please unmute your mic and give the comment. Thank you. The floor is yours.
Thank you so much. This is Irene. I'm biomedical engineer, partners in Health and Sierra. Hematocrit centrifuge is one of the types of centrifuges that we have. They are more of the specialized centrifuges that are used to determine the volume fraction of the of the red blood cells in a given blood sample. So that's specifically about the hematocrit centrifuge. So it's not only a hematocrit centrifuge that is used on the workbench, like after spinning it and then the separation has happened in the strips that they're using to collect the blood. So then they use a certain item that they use to, it's more of a calibrated kind of, they use it to determine what percentage of red blood cells are in the blood sample. So it provides those hematocrit values that can be used for testing in biochemistry, blood testing, like in just general clinical tests. So mostly it's used to diagnose the blood loss. Let's say if someone is having an elevation in red blood cells or maybe having less, to detect anemia, and also maybe it goes up to the case where detection of bone marrow failure or leukemia, something like that. So the other specificity of the hematocrit, it spins most commonly speed that the hematocrit has is something like 11,000 to 15,000 revolutions per minute. So basically, it's the same as any other benchtop centrifuge, but it is it's mostly specialized for the use in the blood samples, not any other fluids that we use for the rest of the centrifuges. For this one, it's only for the blood sample. Thank you so much. Over to you, Kelvin.
All right, I think just to add on them, I think it was Innocent who asked the question, and he wanted to know about the classifications, in which categories. I don't know whether my sister can clarify, because according to my knowledge, I know it's deals with the blood, yes, red blood cells sampling, but again, the classification of medical devices goes under class 1, class 2, class 3. And I think it can be classified either 2 or as either 3, depending on the complexity and the risk that it carries. So I think also it's very important to note, because my brother wanted to know the classification of this. If I get the question correct, probably somebody can clarify. We are all learning. But it can be classified as both, either 2 or 3, but not class 1. That is for sure.
All right. So looking at the time, it seems we are past the time. I would like to thank everyone for attending this webinar. Thank you to all those who asked the questions, made comments. Before we close, the Oxygen Alliance has launched the Best LMIC journal. The link is pasted in the chat, so make sure you go in the chat and open the link and appreciate what the Oxygen Alliance is doing. Thank you, Engineer Joseph, for the wonderful presentation. We do not take this for granted. And thank you to everyone who has attended. Thank you very much. Bye.
Bye. Bye.